Welcome everyone to the Microbit for Beginners 2-hour Educator Workshop. I'm your presenter, Andy Lindsay, and this is the November 13th, 2023 installment. This workshop has a slideshow that accompanies it with lots of links that you might want to follow and come back to later. So I am going to paste that into the meeting chat so that you can get to it. I'd recommend bookmarking it for referring back to later. Should be in your chat now. All right, so one of the things, since this is going to be a partially hands-on workshop, sometimes it's better to have it so that your Zoom is over here and maybe your editor is on the other side of your screen. Those of you with two screens, that's maybe not quite as much of a challenge, but if you have a single screen, wow. Let's see, who can we mute? There. Okay. All right, where was I? Let's see. Yes. So right now, my slideshow is probably filling your whole screen. And so to get it to where you can change the size of the window and move it around, one thing you can do is in the upper right of your screen, there should be a little, you may need to move your mouse to see it. There should be a little view button. And when you click it, you can just hit exit full screen and then reshape the window to whatever size is comfortable for your whatever monitor you're working with. And again, if you have two or more monitors, that may not be needed at all. But for those of you with a single monitor, this might help. And of course, you can also click a little button on top of your window to make it go back to full screen too. So what's in store for today? We're mid introductions and overview. After that, we'll be working on getting as many people started with the microbit. As many of you who have microbits and want to get started, we'll try to get as many of you started as possible with actually transferring a program from your editor, which is going to be a web editor, to the microbit. To make it do something with a program. And we'll also talk about editing, saving, and reopening scripts, writing both block and Python code, and some of the really interesting applications that are available for students to experiment with. It really takes programming and computer science and gives it an extra level of fun and motivation. And we'll take a look at some of the things that are available for that for students. We'll also take a look at some of the things you can plug a microbit into for the sake of circuit, robotic, and cybersecurity courses. And we'll also look at the available teacher resources provided by parallaxcyber.org, and although they're not on there, microbit as well. With you today from right to left are Stephanie Lindsay, our Product and Documentation Manager, Ari Alvarez, Company Vice President of Parallax, and your friendly applications engineer, Andy Lindsay, that's me. And Stephanie is right behind this window here at Parallax, and then I'm kind of a little bit out of the photo right now on the other side of the wall over here on the left. Parallax has 15 employees. We're just outside of Sacramento, California. And we've been providing services and goods to education since 1997. One of the major focus of Parallax is to enable more and more people to either design and or understand the kind of things that go into the electronics and computing in everyday products, as well as cool projects. And for that, we design and manufacture computers called microcontrollers that are programmed, and they're put inside these devices to control and monitor the circuits inside the devices. Our chief inventor is Chip Gracie, and his brother Ken is the company's CEO. I'm Andy Lindsay. My background is in electronics engineering, but for the last 20 or so years, I've been doing educational projects, helping design educational products, and then writing textbooks and web pages and etc. Parallax really got started in education with an invention of Chip's called the basic stamp microcontroller. And so this is a thing that you program and put inside one of those products or projects. And this came out in the late 90s and really took down a lot of barriers that were previously in place for programmable devices and connecting them to electronics. And it became especially popular when we embedded it in a two-wheeled robot. Fast forward 20 some odd years, and additional microcontrollers that have made things more powerful or brought down barriers have come on the scene since, and we've done robots for several of them. And the most recent and really the most accessible, easily accessible microcontroller is today the microbit that we're going to be talking about. And this module, in addition to bringing down a lot of the barriers to programming devices that can talk with electronics, it also brings down barriers in terms of just being easy to get started with. Most of its predecessors, you had to install special software on the computer, and with the microbit, that's no longer the case. As long as you have a web browser, most computers can be used to program the microbit. Incidentally, the Cyberbot robot, which is something that you can plug a microbit into, is a project that was co-developed between Parallax and Cyber.org. Cyber.org is Department of Homeland Security funded. Their goal is to create a cyber-ready workforce, and to do so, they develop and supply curricula to U.S. educators. We'll be taking a closer look at some of their offerings right near the end of the presentation. I should also mention that they have all underwritten certain portions of the materials that you'll be looking at today. So thank you, cyber.org. Okay, now on with the microbit. The microbit, one thing that's really neat about the microbit is it's a thing that you can plug into your computer and write programs and zap it to the microbit and make it run the programs over a USB cable. And it's kind of, in a way, a microcosm of a cell phone, which makes it kind of attractive to young people, given how much time and fascination they have for their phones. And the fact that it's something that you can write a custom program for gives us a lot of opportunities to impart certain computer science, electronics, robotics, cybersecurity, you name it. There's a lot of ways that this device can be a vehicle for imparting knowledge and skills into young minds. In terms of its similarity to a cell phone, well, first off, cell phone has a display, microbit has a display. Cell phone has a touch interface, microbit has a touch interface. Now, granted, it's much simpler, but it also is around $20, so it's much less expensive. So we have 2 push buttons for our touch interface, plus on the version 2 microbit at a little touch pad. So there's 3 buttons that can be pressed. It also has a microphone for detecting certain sounds, a speaker for playing music, rudimentary speech synthesis, and some other fun stuff, simple tones, video games, sound effects, etc. The processor is right here on the back of the microbit, and this is the programmable thing that we write code for. But it also it's got a compass inside it. It's got an accelerometer, which is a tilt sensor inside it. I think I mentioned the speaker and mic already. Let's see here. It does have some rudimentary temperature and light sensing as well, though that's not shown on here. And its predecessor with a little bit less program memory, the version 1 microbit, does not have a touchpad, and it does not have a built-in speaker or a built-in mic. And it's got a little bit less memory, but either one will work fine for today. Okay, so that concludes our introductions and overview. And now we're going to move to setting up your microbit module programming connection. And what this is kind of, this slide is very similar to the email I sent out. These are all pretty much the same links. I hope you had a chance to try it, but if not, I think we'll take a close look at it here. So we'll start with the make code block editor version. And so I'm going to copy this link and paste it to you. And what I'd recommend is probably opening it in a new tab on your browser. And you'll want to make sure that that's either Chrome or Microsoft Edge. I am using Chrome today. Okay, I need to paste that to you still. Okay, so here's a link to that in the chat. And then there's an introduction tutorial page. These 3 steps are really all on the same page. It's just different tabs. So I'll copy the first one over and we'll talk about it briefly. Now, normally what I like to do is I like to, both for myself and for myself as a student and for students, it's really helpful to have your tutorial side by side with what you're going to be using to edit the script. So in this example, I have the tutorial on the left in a web page, and then that's the microbit.org getting started introduction page. And then on the right is the makecode.microbit.org. And that's the editor that we'll be using to work with block code that will load into the microbit. Now, so on this getting started page, this is just sort of what is the microbit, and it's a little video that you can watch. And then when you're done going to step 2, they're assuming that your microbit came straight out of the box for step 2. Now, if it's in the classroom, well, first of all, I'll show you the out-of-the-box experience, and then I'll share a link for how to restore a microbit to out-of-the-box for like a next semester. So when you take it out of the box, there's a battery pack, batteries, and the microbit itself. And once you've got all those things, it takes you step by step through connecting the batteries and plugging it in. And then there's a little program running inside the microbit, and it reacts to your pressing the buttons, and it reacts to your shaking it, and it reacts to your touching and speaking at it. And then it's got a nice tip at the bottom here that if you press and hold the reset button underneath the microbit for 4 seconds, that'll turn its power off, which will definitely save on your batteries if you leave them connected. I typically prefer to also take the batteries out of the pack when not in use, just to make sure there's no power drain. Okay, then on to step 3, and this is what I emailed you, or this is where this I believe was what a link that I emailed you, and we're going to focus on, there is a tablet version, but we'll focus on using the microbit connected to a computer with a USB cable today. And so selecting that and then hitting next, it tells you what you'll need, which is a computer, a USB cable, and your microbit. And once you've got all those things, then we're ready to go And this is the step-by-step that we had you go through. And this is probably a very important step-by-step. I'm going to paste the link to this particular page just so you've got it. And so it's in the chat log so that anybody who's watching this later can get to it as well. And note that there's also iPad and Android device tabs here if you're using those. And there are some caveats. There are some things that are microbit only, but might not be supported by, say, certain cyberbot robot applications. If you're thinking about using iPad or Android, I'll try to come back around to that. All right, so here we have the first video in the tutorial, and it's a great little video, and I'll just kind of talk through what they're talking about in the video. Actually, if I could get a quick thing to find out if the sound is still coming through from my computer. Now, was that audible? Yes, no? Not audible. Okay. Okay, well, fortunately, we have the subscripts here. And the first thing that this particular video tells you to do is to click the new, to go to makecode.microbit.org and click new project and give it a name. And I think it was name badge. Yeah, I can't get quite there, but let's just do it as name badge. So in your makecode.microbit.org, click the new project button and then type in name badge and then hit create. And then they give you a little tour about all the little pieces. And I recommend going through that, but I'm going to skip that for now because I'll point out the various pieces they talk about in the tour. So here we have our editor. And in this video, what they do is they tell you, okay, drag the on start block off of the screen to discard it because it's not going to be used in this example. See if I can zoom in a little bit here. Zoom in the lower right, and then there's repeat and undo actions. Little save button for saving a local copy. Download is downloading from here to your microbit. And then there's a way to get back home. And here's the name badge I was just working on to return back to it. Now, the video tells you next to grab the show string block. And so that's by clicking basic and then clicking show string. And then when it places on the canvas, it places as gray. But if you drag and drop it into the repeat forever block, it changes to blue, which means it's ready to execute. Furthermore, right as soon as you do that, the simulator starts showing you what to expect from your real microbit once you load the script in. You can also stop that simulation with the stop button, restart it. There's even a debugger that will show you what step you're on. There, you can turn the audio on and off, take a screenshot, fill up the screen with it. I'm going to click the debugger again to get out of that. But it is really nice. You can step through, set breakpoints, all of the things you would do with the debugger. Let's see, having power connection issues, not sure why. I do not know either. The main thing is you won't need the battery pack for this. If you use the USB cable that came with your microbit, just plugging it into your computer should power the microbit as well. All right, so continuing on, so we have a program here that looks like it should work on the simulator. And since it's called name badge at the end of the video, what they did was they also said, hey, why don't you put your name in there? So there we are. And then they talk about transferring to the microbit, and they say it's really short here. They say basically, well, just hit the download button. And when you do, it's gonna do, it's gonna tell you a few things. And I just want to point out that this area below that, this hasn't worked. I don't see my name on the microbit yet, is worth clicking just to see the video of how to transfer, and what to expect when you're transferring a program from makecode.microbit.org to your microbit. So, so hitting download, what the video here is going to tell you about is that when you hit download, oh, darn it. I forgot I already connected my microbit. So that's not what it's going to look like. So I'm going to disconnect my microbit. Okay, so hopefully if I hit download now, yes. So when you hit download, there will be a pop-up saying, first of all, make sure to connect your microbit to your computer, and hit next. And then this next pop-up is basically warning you what's going to happen in the pop-up that follows it, which is you need to click BBC microbit in the next pop-up, and then click connect. Okay, so when I hit pair, it's going to give me a pop-up where I have to choose the microbit and then hit connect. We'll choose that one and hit connect. And I have two microbits. One is, I'm going to try that again. Okay, next, pair, try the other one, connect. Okay, now it says we're connected. I have two because I'm going to be using two different editors. And so I wanted to basically, when you switch editors, it takes a while the first time you load the script. And so I was going to try to save a little bit of time there. So here it's saying now you're connected to the microbit. And when I download now, instead of downloading the script to my downloads folder, it's going to download it to the microbit. And so here it's showing the progress as the script that's supposed to display Andy is loaded into the microbit. And there's a flickering light by a USB cable here that that will continue to flicker until it's done downloading. And then once the program is loaded, then it'll display ANDY exclamation point, just as it did in the simulator. Get that second microbit out of the way for now. Okay, for any of you who are experimenting along with this, is it working? Can I get a thumbs up from? Oh, looking good. Right on, Max. See a few people looking down, so it looks like you're still working on it. Okay, and incidentally, it's fine for those of you who, definitely just watching and then trying stuff later is a good approach too. And I'll be available if at any point you run into a stumbling block that you feel like you can't reasonably get past, just send me an email and we can even meet over Zoom to make sure that wherever you're stuck, you can be unstuck. Okay. So that is the basics of loading a program into the microbit with the block editor. Now let's go back and take a look at the microbit Python editor version of this. So I'm going to copy this link and paste it in. You can try opening the microbit Python editor. And then here is the first of two get started pages that are of interest for using Python to write a script and load it into your microbit. I'm going to go back to my pair of screens and let's see here. So here's the Python editor link. No, that's the tutorial link. Okay, I got to go back and grab the Python editor link. Okay, so for some of you, you might get the whole left panel plus simulator panel. But as you squeeze the width of the editor down, first the left panel disappears, and I think I can squeeze it to where the simulator panel will disappear. You can make those disappear and reappear by the little expand collapse arrows.
You want to answer specific tech questions now for people who are having trouble?
Yeah, well, I will try. It's kind of
Okay.
difficult because what ends up happening is all of a sudden 25 minutes has gone by and we end up losing the whole thing. So I'm going to help as much as I can.
Okay, Sharon has chatted that I can't seem to click on the connect button. I downloaded and paired, but it can't connect. Have you ever seen that?
Let's see, if you're paired, okay, so here we are. I'm not exactly sure what's happening there. I'm going to give several ideas. First, here we have the make code editor. And if you were able to download and pair here, you might need to disconnect here before coming over to this other editor. And then clicking connect. So that's a possibility.
So it might just be being paired to a previous tab.
Yeah. Okay. And let's see here. But normally, for example, you should be able to have multiple instances of make code going. It just might be a little bit difficult. See if I can get.
Is it ever a bandwidth issue while on Zoom?
That can happen too, though. Actually having the connect grayed out, like when you choose a microbit, if you want to connect to it, as soon as you choose it, and you're typically going to have one, it should just turn blue. And so what I'm hearing is that it stayed gray.
Okay, so that could be a bandwidth thing.
Yeah.
Okay. Well, I don't want to hold you up.
Okay.
Just wanted to throw this up there.
Well, I'm having, I think, some trouble I made for myself by connecting two microbits. Let's see here. If I that should really nuke everything. Okay, let's try connecting again. Try connecting. I think that maybe I should unplug my microbits. And I can that time-saving little thing I did ended up helping me shoot myself in the foot. So let's see if, okay, so I see that right now, this microbit is still connected to, yeah, it automatically connected to the make code editor. So there's 3 dots to the right of download, and you can click disconnect. And then hopefully, if we come over here and hit connect, there we go. Microbit ready to flash. All right, so I got a little bit ahead of myself actually, because what this process I just did was here's the first page in the tutorial, and it basically talks about how you're going to need a computer, a USB cable, and a microbit, and also it mentions a USB-C to A adapter in case your computer only has USB-C ports. And then there's another step-by-step video. This one's very step-by-step. It meticulously goes through how you'll, which browsers you'll need to use, and, what you might experience on the first time to the site. And here's what the editor looks like. And it's talking about using the simulator again. So this is, again, very step-by-step. And it's telling you, okay, well, when you hit send to microbit, it's going to show you that you need to connect the microbit and with the little pop-up. And so then it shows us doing it. Here we are plugging in the microbit. And then it goes through the whole set of steps where, for example, the pop-ups that are warning you what you're going to see next, and then how to select the BBC microbit and click the connect button, and etc. So that's all the same stuff. And then once you're connected, there's a disconnect option, but once you're connected, every time you send a microbit, well, if the microbit was programmed previously with the make code editor, it's going to go slow the first time that it gets programmed with the Python editor, and vice versa.
I want to report that Sharon did get it connected.
Oh, excellent, Sharon. If you have any comments about if there was any particular thing that you did to get it to respond, let us know. Oftentimes it's just unplugging and replugging the microbit, or disconnecting at one place and then connecting at another. Okay, so I forgot to simulate this one. So this one is going to display a heart followed by the message hello repeatedly. And so going over to the microbit itself, here's our heart, and then the hello message. And so those are the 2 examples of setting up your microbit module programming connection. And I want to emphasize that this is, well, it's kind of a big deal because there isn't any need to install any special software. So many microcontrollers out there, you have to have your IT install a piece of software on all the computers in order to get the computer to talk with the module. And with the microbit, that's not the case. It's as plug and play as can be.
Sharon reports I needed to reset the microbit, then select the microbit before clicking connect.
Well, that's interesting. Okay, so did you press and release the reset button to reset it? Is that the type of reset?
As compared to the reset in the editor.
Yeah, I don't know that, because the only reset I know of is the reset in the simulator.
Unplugged the microbit. That's another way to reset.
Yeah. a hard reset.
Yes.
And yeah, that's if that's definitely the next thing. If refreshing the web page doesn't fix it, resetting should do it. All right. So in addition to the video on this page that I gave you the link for, actually, I'll give you the link for this page. It's okay. So this page also has, so we started here with what we're going to do and what we need. And then here's the flashing the script one with the video. And then below the video, there's step-by-step checkmark instructions on the whole process as well. And this navigates page by page. This is learn.parallax.com, by the way. And so here's a challenge to the students to modify the script and then load it again. So this modification was changing heart to happy. And then changing hello to hi. And now that the microbit's connected, microbit ready to flash, and a disconnect option when you click the 3 dots by send to microbit. Now when you hit send to microbit, the script loads very quickly. And here we are with the happy face and the hi over and over again. So this slide, I hope you will find helpful as a reference for getting started. And then I really think that these two tutorials are the minimum, most concise way to get folks started on the left with the make code editor and on the right with the microbit Python editor. Moving on to editing and saving scripts. Okay, so let's go back to the make code editor. Here we have the name badge script. Now, I can save this and it'll go to my downloads. I've actually saved it a couple times already, so I'm on the 4th iteration of this. Let's do a 5th iteration. I'll change my name to Andrew and save it again. And here it tells me, okay, we just downloaded this script. Now, there are several ways to open a script you worked on previously, or a previous incarnation of your script, a previous numbered version of your script. So I'm up to number 5 right now, and we can usually see those in our downloads folder. Now that might be in Windows Explorer, or it might be, if you have a Mac, it might be Mac Finder. But regardless of whether it's a Chromebook, a Mac, or a Windows machine, there's a file browser in let's see, just a sec. I gotta try to remind myself of the app's name here. Okay, in Microsoft, it is called the Files app, File Explorer. Okay, so that's what it is in Microsoft speak, is File Explorer. In Mac, it is Finder, and in Chromebook, I think it's called the Files app. And regardless of which computer you have, it's going to look pretty similar. It's going to show things in your computer like documents and downloads along the left, and then when you click your downloads, it'll show you the contents of your downloads folder. And so here we are with, I've been making changes and hitting the save button And each time it downloads another version of microbit name badge.hex. And so these are the files that contain the program. And one thing I can do is I can take the version 4 and drag and drop it from my file browser right onto the editor. And lo and behold, it changed from Andrew back to Andy. And then I'll take the one that has a 5 appended to it and drag that on. And then we are back to Andrew as the name in the string. And so this is an example of how to save a local copy of your file, because you can go home here and you can see several instances of name badge, like the 2 minutes ago version and the 20 seconds ago version, and etc. And those will stay, but if you're going to a different computer or if you're using a different browser, you might need to go to, say, a flash drive and grab the hex file that you were working with and open it. Now, some of you may notice that the drag and drop of a hex file onto your editor doesn't work. If that's the case, you can just go home, and then there's an import button. And when you hit the import button, you can import a file. There's also URL in GitHub repositories, but let's stick with something simple like the file. And then you can choose the file and then browse to your downloads and pick the file you want to open. And then there we are. So that's the way to save, with the little floppy disk save button down at the bottom. And then open. I'll refresh this and I'll get the version 6 of name badge. And so this is the way to, and it's easy enough to say, okay, well, this is the one I want to keep, and then you can delete all the others. But do make sure not to delete too heavily and end up losing your work.
Here's a question. Does it make a difference if you log in?
I don't know.
I never have.
I never have either. We just assume the whole COPPA compliance thing, and that that students aren't going to be logging in. Sorry, I will, if somebody knows the question, go ahead and throw it in the chat. My thought was that signing in had a lot more to do with getting to your own personal GitHub repository for that kind of thing, but I may be mistaken there. Wish I'd done that in my prep. Sorry about that, folks. So let's see. We'll wait. Hopefully somebody's tried the login. Otherwise, I will email you a little explanation of the sign-in for this after the workshop. All right, so moving over to saving with the make code, or with the Python editor. Okay, so this was the make code editor that you can use the save button to download, and then use the go home and import, or drag and drop from a file browser. So those are the two ways at the most basic level. And in this chapter that you have, where we've looked at the first activity of connecting and loading a script, a little further down, after learning some more about the editor controls, there's a save and edit scripts tutorial. And here we go with that in your chat. And again, it has a step-by-step video, and then the steps show in check marks. So what I'm going to do is save this script, and anybody who wants to paste into their instance of the Python editor, if they're running it, there's the script that I have modified. So if we have this modified script, let's save it, and here is the save button, and it does the same thing. which is, oh, I skipped giving it a name. So let's see. Happy face, hi, message. That was part of the video, was to give your script a name. And that's right here. You just click the name at the top, and then you can edit the name and confirm. Now that the script has a name, hit save. And it tells you, all right, look in your downloads. Okay, going back to my downloads in my file browser. And I need to refresh it. And then here is happy face, hi message. It's a little bit difficult to see, but there it is. Now, another thing I can do is change this back to the original. So instead of happy, we'll do heart. And I think that instead of hi, it was hello. I don't remember whether it had an exclamation point or not, but this is probably what the default script looks like. So now that we've saved it, I've changed it, but let's say I want to go back. I want to reopen the previous one. So we can change this one to default script, Python script, and then save that too. And one thing to be careful of is that although both of these files are the same type, only files that were written in the Python editor will load into the Python editor and vice versa. So basically, normally students are working with either one or the other. So this is a little bit of a special case. But here I have happy face, hi message, and then default Python script. And the same approach works where I can grab happy. So right now I have the default Python script. And if I want to open happy face, hi message, I can drag it from my file browser onto the editor and then hit send to microbit. One thing I should also note is that you can load it into your microbit straight through the file browser. It just takes a little longer is all. So if you look at the file browser here, your microbit is going to show up as a flash drive. And so if I want to load happy face, hi message, or let's see what's running first. Okay, that's happy hi. Okay, so let's move back and put default script in the microbit, but let's do it through the file browser. And again, this will work in Finder, File Explorer. That's Windows File Explorer, Mac Finder, and Chromebook Files app. You can, in any one of those, drag your file and then drop it right onto the microbit, just like it's a flash drive and you're copying a file over. Now it takes a while to do this, but it's and actually that went pretty quickly. So now instead of the happy face and the hi message, let's see what we've got. Oh my, I'm just really having the best of luck today. That's a dire message I just got. Let's see here if I drag and drop one more time onto the microbit. Ah, there we are. Okay. So here we are now with the default script of a heart and a hello message. So that's another way with any hex file that's generated, be it from MakeCode or from the Python editor. I also want to point out, though, that here's name badge, one of the name badge iterations. And if that's one that I developed, that I wrote in the MakeCode editor. So here it opens nicely in the MakeCode editor. But if I try to open namebadge.hex in the Python editor, it gives me a warning that it cannot load the file because and it actually sends me over to makecode.microbit.org to use that hex file, which is nice. So keep that in mind, that these .hex files are either going to be generated by and openable with one editor or the other. All right. Did we ever get any answer on the sign-in merits?
Yes, we have a couple of responses on that. One confirming that they have an option to save to the cloud from the block editor, and Jackie also notes that the Python interface does not have this save in cloud feature.
Yes, this is true. So save in cloud is available through the MakeCode editor, yes, but not through the microbit Python editor. That's all local files.
Yeah. And Ari mentions in our curriculum we use the Python editor, and even if we were to use a block editor, we'd probably stay away from creating an account due to the COPPA compliance situation.
Yes, yes. Okay, perfect. Thank you, everyone, for the input. Next up, so I think that concludes the save and, oh, well, I should point out that there's also an open button. So if for whatever reason drag and drop doesn't work, if you click open, it should put you in the downloads, and then you can reopen whatever script you were working on. Okay, next up, writing block code and Python scripts to interact with the microbit display and sensors. This is where it gets fun. And the first place I'd like to show you for this is, this is great, and it doesn't matter whether it's a warm-up for a really challenging full cybersecurity and cyberbot robot and microbit and computer science, everything year-long course, or if it's just for, a few class periods as kind of an enrichment activity that introduces coding. This Make It Code It page on microbit.org is just great. So I'll copy and paste paste that web address. Definitely bookmark this one. This is a set of tutorials that has students try out things with the microbit completed programs and then modify them to customize them for themselves. And along the way, what the students get to see is, well, for example, if we think about programming, the things that we program a device to do. One is communicate. And so we're using the display to communicate, in this case, a heart. Then repetitive things are things that computing devices do. Looping routines. And so here we have a beating heart. That's an example of a loop. Coming further down, an emotion badge, where if you press one button, it'll smile, and maybe another button, it will frown. That's conditionals. That's if one button is pressed, then display one thing, otherwise display something else. Moving down, when we get to dice and magic 8-ball, there is calculations added to the picture. And then by the time we get to step counter, well, that's a whole lot because, open this in a new window. Step counter also adds in storing and retrieving values, remembering how many steps were taken to add to it. And as I said before, this is the kind of thing where the students are provided with working code, and then they're challenged to improve it. And this particular code, and most of the examples in the Make It Code It page, offer you Make Code or Python. So here's the Make Code version, and it even lets you open it in Make Code. So it takes you right there, and it has the project ready for you to load into the microbit. And especially for students who are younger and have a shorter attention span, this is, you know, a great thing because they get something that works instantly. Now, another approach to this might be, oops, I wanted step counter again. Okay, so and I pasted that in so you guys can see it too. Okay, so if we go to the step counter tutorial, and we're currently looking at the Make Code version, yes, you can open it in Classroom, which I'll try to loop back to. It's a nice virtual gathering place where you can share code or snippets with your students and monitor the students as they're solving whatever problem they're working on. And it's also COPPA compliant. It is completely anonymized, and so no student data is retained. And so you can share, like I said, code or snippets with your students and observe their screens as they're working on making the code work correctly. And that works for both Python and Make Code. But I don't want to, like I said, I'm going to try to loop back on that if time permits. For right now, you could open the this project in Make Code. You can also download the hex file, and then you can open it in Python as well. And so here I have the completed for me example in Make Code blocks. And then here also is the completed example in Python. And again, this is one of many things that students can go through and rapid fire try and modify to have fun. And like I said, it's great for some kind of enhancement workshop, but it's also great for the start of a much larger course, just as kind of a warm-up exercise or icebreaker to experiment with these for a while. And so either one, if you run it, let's see here. You have it, so you can open either one. And then when you run it, see, I don't remember. I think I ran the Python last, so I'll send it to microbit on the Python. Okay, so what this says here, this unable to claim interface, it's because I'm already connected over here, I believe. So, so if I take this script and copy it and paste it into my original editor, let's see if it lets me claim the interface. Yeah, there we go. Okay, so so that's a thing to keep in mind, is it's probably better to do all your work in a single instance of whichever editor you're on. I do know that this Make Code editor has allowed me to switch back and forth between two different editors. and it did seem to work, but I just saw now that it didn't work out so well with the Python editor. At any rate, now that this is in the microbit, we can take a look at it. And all you have to do is give it a shake. And each time you give it a shake, it will increase the number of steps that have been counted. And it's this kind of thing that I think makes the microbit really great for being a device that's both fun and highly useful in terms of learning computer science concepts and computer science and programming concepts.
Here's a question.
Yes.
And which is answered. Is there a way to create a classroom and see what the students are doing, like in Scratch programming? I'm sure there is no such feature, but it would be nice to have it someday.
All right. We better just take a look at this. Okay, so I'm going to open, I'm going to open a more simple project in, okay. I'm going to go to the step counter, copy link, paste and go, open in classroom. Okay, so project step counter, we'll do this in make code. And what it's showing you is what the students are going to start with, which is 2 empty blocks. And then it's going to, and then it shows the completed version. Let's see here. So when I start the session, it's starting with that blank version, and I want to now invite all of you. Okay, so I just copied the student invitation link, and we'll go ahead and paste that into the chat, and you guys can all join me. And I think you can put your name in and everything. Okay, so there's Jackie. Now let's see what Jackie has. So Jackie has the same on start and forever. And let's see, as the teacher, I'm going to edit the code. And I don't know if you can see me editing the code, but I'll like give a hint that, let's see here. Input. And then there's accelerometer. Okay, so I'm going to go back as the teacher and take a look at my finished project. So the question though was, can you see the student's code? And so as the teacher, if I say, okay, I'm taking a look at the setup here, and we're gonna do set steps to 0. And so I could say, okay, to start out, I'll go ahead and use the variables and I'll make a variable called steps. And then we're going to set steps to 0, and we'll put that in the on start. And then basically now I can send that, I'm going to send that to Max. And I think I just edited Max's code. And I actually wanted to send that to everybody. So here's my code. And if I edit from here, hopefully that'll work a little bit better. So variables, make a variable, steps, set steps to 0, boom. Okay, so here's your first hint, everybody. And when I send that, I can select everybody and hit send code. And then you get to choose whether to receive the code or not. And then I can go back and I can take a look and see whether Ari, oh, look at that. Ari's already going to town with the script getting to the end point.
Yeah, I didn't accept your call because I'm not sure if he will delete mine, so
I think
declined.
it would have set you back. Meanwhile, Jackie has the code. So this in answer to your question, yes, there is a way to create a classroom and see what students are doing, like in Scratch programming.
That was Leo who asked and answered. Thank you. That I learned something there myself.
Yeah, it's a pretty impressive little system. I really like Classroom.
Okay.
Okay, everybody, I'm going to go ahead and end the session so we can move on to the next thing. All right. So again, make it, code it, definitely bookmark it. For a more in-depth look at, say, Python, because the lessons in Make It Code It are very having the experience. They're not necessarily as structured as some teachers need them. And so another approach, so some teachers need this really open classroom, creative play while you learn kind of feeling. Now, on the other end of the spectrum, we can take a look at some of these basics. And the best place I know of right now, or that I can think of, and this is a Python example here, is our cybersecurity series. The prerequisites are a lot of Python basics. And then the main lessons, I still think that everybody should try radio basics and radio data, even though it's in the main cybersecurity lessons. But these right here, how to save and reopen a script, and writing microbit programs especially is a good example of, again, the coding basics, the display for communication, variable setting and recalling, calculations, decisions with conditionals, repetitive actions with looping, using constants, and then on to push buttons, writing functions, and talking about variable scope. So this is an example of a different kind of set of lessons that still uses the microbit. And so, for example, if we look at make decisions here, here's a situation where if you've got students learning and you're going to be quizzing them about it and that kind of stuff, it's a good idea to make sure that they know that they'll have a better chance of succeeding if they tile their tutorials side by side with the editor and actually type the whole thing in. So literally, you know, A equals 89, B equals 42, and so on and so forth. And I'm not going to take the time to type the whole rest of it in. But the idea is that if students do this, the coding technique is going to sink in a lot better than if they just copy and paste it like I just did for the sake of saving time. And so that's a really powerful thing, is to go through, basically read the explanation, follow the instructions, enter the code, and then run it. And let's see, I'm expecting the microbit to display A is greater than B. And so we can simulate that. A is Greater, yeah. It says A is greater than B, and we'll go ahead and send that to the microbit, and we'll be able to see that over here too. I'm going to restart it by pressing and releasing the reset button underneath the microbit. One more time. A is greater than B. And then going through, reading the explanation, trying a modification. And this set of tutorials takes a much closer look at the various scripting concepts and in a more rigorous fashion. So that's another example of where to learn scripting. And as teachers, if you have to teach at this level, definitely go through this yourself. Hand copy as many of these code examples as you can, because that's what's going to essentially help you feel confident if you're new to a particular programming language as well. Okay, coming up on 45 minutes left. How am I doing? Okay, so this is the example I went to, was writing microbit programs, and there's a whole bunch more there. So there's examples on talking to the microbit through a terminal. There's a primer for dictionaries, exception handling, strings and characters, and then of course there's all the basics in the writing microbit programs. So these cover a lot of the basics, but in a much more in-depth way. So that's another example of how to approach teaching with the microbit that may be useful to some of you. And so next up, we are going to talk about how the microbit can be plugged into or connected to other devices and circuits for the sake of cybersecurity, robotics, and electronics lessons. We'll start with robotics since that's the most popular. I mentioned earlier that the microbit has a radio inside it, and that really opens up a lot of cool possibilities. In addition to having this little breadboard, this white proto board for plugging circuits into, and the microbit can monitor and control circuits that are connected to here. It can also control the servo motors that are connected up there that make the robot roll. And the fact that it has an accelerometer and a radio built into it, that being the microbit, opens up a lot of fun things that can be done. Like here's an example of a teacher computer and a class set of robots as another icebreaker for radio communication. And the script that's running is allowing him to enter numbers into the terminal to tell the robot what direction to go or how fast to turn each of its wheels and how long to do that. And so here he's setting the speeds to full speed with both wheels and then a certain number of milliseconds to run. And the entire class of cyberbots are all receiving those radio commands from the one microbit that is connected to the computer. So right there, there's a microbit connected to the computer, and it's broadcasting to the microbits on all these cyberbot robots. See if I can get a better shot of that microbit. There it is. Okay, so here is the one microbit that's connected to the computer, and everybody else is on a battery supply, but they're all on the same radio channel. So anything that gets sent out gets because of all these cyberbots have the same script running in them to listen for radio instructions on what maneuver to take, they do it. And this is also kind of neat for cybersecurity because this radio can be configured to be wide open, just like the internet fundamentally is. And then you have to start adding layers of encryption in order to harden your network so that somebody doesn't hack your robot. This is the table of contents for the cyberbot robot, and we have all those same computer science basics that I talked about for cybersecurity. Then we have the robotic and electronic activities, and then some fun radio stuff, and then on into cybersecurity where you start hacking each other's robots and trying to prevent that from happening to you. Going back to the beginning of the robotics, basic navigation, this is an example of what the Python script looks like to make the robot go forward and then hang a right and then stop. Now, if you say, all right, impress me, draw a box. Well, a student might take this routine and copy and paste it 4 times, which is well and good, but we can give extra points for using a loop to do it after having gone through the basics. The students will know about loops, and so they can instead, for the extra points, use the for loop in Python to repeat the one maneuver 4 times. And here we have an important computer science concept checkbox. Once you add sensors to your robot, it can be programmed to, for example, detect when it's bumped into an object using switches. We call them whiskers. It can be programmed to monitor light sensors so that when it sees a flashlight, it follows along with it. It can be programmed with infrared flashlights that it shines ahead of itself, and when it sees the light bouncing off an object, it turns away from it without bumping into it like it did with the whiskers. And then there's some fun things like extra things that you can add on, like this device is called the gripper. And instead of using the computer to type out navigation, a separate microbit is monitoring its own level of tilt and then sending that to the Cyberbot robot. And we're also using the push buttons on the microbit to open and close the gripper. So the microbit that is being held is detecting tilt and then button presses. And then those are being broadcast to the robot. And the robot, based on those tilt measurement numbers, sets its wheel speeds accordingly. And then, of course, grabs and releases its gripper on an object. So that's an example of something that can be done with some add-ons. That's not part of the stock kit. And there's all kinds of add-ons, like for line following and using sonar to detect objects on a little turret. So those are some fun things, and those are all, again, part of the chapter. So these are the add-ons. It's a little out of date because it's not showing the one I just put on the video. And then some of the other chapters here are, for example, this is the whiskers, and then the light and the infrared flashlights. On the cybersecurity part, you can do it microbit only. And then each microbit, or each lesson, also has an extra part where you're using the Cyberbot. And so, well, there are many of these lessons that also have Cyberbot options after microbit only options. And so, so you might be doing radio data, and that's just exchanging data between 2 microbits. But later on, under sniffing attacks and defenses, there will be a microbit option and a Cyberbot option that you can try. And I think like malformed packets and defenses is probably the best example of that, except for I forgot to paste in the link. So I'm going to back up a little bit. And malformed packet attacks and defenses. So this explains how to do it with just a microbit first. And it shows you, this is the microbits connected to a terminal. And that terminal, by the way, is, so for example, if I wanted to use the terminal, I could say, I'm going to give it some time. 1.5 seconds, and then print hello. Okay, now that's different from display.show hello. Print hello will only go to a terminal. Display.show hello will go to the microbit. I'm going to use a hashtag to make this a not command. So this is a way to comment a statement in Python. And so now print hello, if I simulate it, oh yeah, if I simulate it, I need to show the serial and then restart it. And where is the hello? There it is, right at the top. And then it just shows you a bunch of stuff because the program ran out. And so this is displayed every time a program runs out. Now, if I instead use display.show hello, then if we simulate it, nothing appears in the, well, hello does not appear in the serial, but it does appear on the display. So that's a distinction to make, and you can even do them both. But just know that if you're printing, that it goes to a terminal. And by the way, there's a show serial button at the bottom. So this is the real microbit. This is the non-simulated version. So if I send it to the microbit, there it printed hello, but it's also displaying hello. I'll go ahead and restart it. So there's an FYI, is that you have a terminal where you can do a lot of stuff. And that again was where values were being entered to make that classroom full of robots do different maneuvers. And I think I got myself a little bit off track with that. Let's get back on topic. Oh, so print and the terminal is used quite a lot in the cybersecurity lessons. And so this is an example where we have working code where one microbit sends another microbit a countdown timer. Like maybe it's controlling a model rocket launch. But this microbit was, the sending microbit was also loaded with a way to send a malformed packet to the receiver microbit so that instead of counting down, it just freezes in its tracks. And so this set of lessons does this for, this terminal application. And then it also does it for an application where two microbits are sending images back and forth to each other. And there's a way to, if the microbit has been programmed by a malicious actor, when they get to the skull and they hit send, instead of displaying the corresponding skull, it ends up causing the microbit to no longer work correctly until you either restart it or reload the program or what have you. And then it goes through how to figure out that that's happening, how to prevent it using coding concepts that were introduced earlier. And then here, for example, we have the Cyberbot robot version where this is the same keyboard control video you saw earlier. Students are pairing off and hardening their Cyberbot robots against receiving a packet that's telling them nonsense to prevent the robot from stopping in its tracks so that it can perform better in, say, a contest. We also have the ability to connect the microbit to an electronics platform for learning electronics. similar prerequisites, not quite as many as in the computer science heavy cybersecurity. But the cool thing for those who need it is that there are lessons in things like what is voltage and how do you measure it? And how does that work in a schematic? So what's happening here is the microbit's underneath and it's plugged into an adapter, which is plugged into an electrical and electronic prototyping board. And the microbit is running a program that is forwarding data to an application called the cyberscope. And the cyberscope in this case is set to display the voltage that are measured, the voltages in the circuit that are measured by these probes. And then there's a lesson on how all the voltages in the series circuit have to add up to the total voltage applied to the circuit. And so that's why 3.26 equals 1.20 plus 2.26 or 2.06. And the cyberscope itself can also do measuring using a device called an oscilloscope. And this gives students an opportunity to see visually how certain professionals test various electrical signals. Like this is an example of the graph of an electrical signal that tells a servo to turn to and hold a particular position. And a servo is a little motor with an armature that can turn to and hold certain positions. And the lesson kicks off with, okay, here's the amount of time that this 3.3 volt brief high time gets transmitted, and then there's some low time between it. And depending on the amount of time it stays high, you get a different angle out of the servo. And it's a popular thing in various mechatronic and animatronic student demos. And so this is a way of, or this offers a way of taking a deeper dive and actually measuring the electrical signals that are being exchanged between the microbit and the servo. And cyberscope.parallax.com is, by the way, the place where this is, and it has a little video that you can use to see how to do it. And it takes you step by step through downloading a hex file, opening it, loading it into the microbit, and then going to cyberscope.parallax.com. And cyberscope.parallax.com has the same connect ability with the microbit that that the make code and the make code and the Python editor have. And so after you connect it, if the microbit's running a script that sends its signal measurements, this is an actual demo of the signal measurements. And it's not connected to any circuits. It's just basically demonstrating, hey, these are the kind of signals that you can see, and they're and an oscilloscope feature to zoom in on the time base of those signals and freeze them to a particular reference point. There, it just lined up with this purple line are things that are part of learning electronics. And then there's also the common meters that are used. There's a thing called a multimeter, and the most common measurements are voltage, current, and resistance. And so we just saw it go through those set of measurements as well. Do that one more time. So there's our voltage measurements, resistance measurements, and here are the current measurements as well in amps and milliamps and microamps. So those are all things that are used in that set of tutorials. Okay, last but definitely far from least, locating student and teacher resources for the microbit at Parallax and cyber.org. That's going to include both purchasing, student guided lessons, and teacher guided lessons. So let's get started. First of all, for purchasing, there's a shop button at www.parallax.com. And let's see here. I want to make sure I get this right. Shop. Okay, so that's the top level one. Then next up is for microbits. There's a microbit category. So this is all things microbit available through Parallax. It includes some of the kits I demoed. And there's the link to that. And at its most basic, if you're just getting a microbit Go bundle, that would be this guy right here. So that's the kit that has the USB cable, the batteries, and the microbit. And it retails at $18. There are a couple of others that are notable. One is for equipping your classroom. There's a club bundle. So that's 10 of those. And it looks like you save $5 over purchasing the microbits on their own. Copy link, paste. And then here's the Cyberbot robot, if anybody's interested in taking a look at that. And when you open these links, there are educator discounts. Wherever possible, we put them right on the page, so you can set up your purchase order accordingly. We show the various, if you purchase 10 to 19, it goes down by 5%. If you purchase over 20, it goes down by 10%. As far as student lessons and teacher resources, for Parallax, what we offer is on learn.parallax.com. And I better give you that link. Okay, so this is student resources. It's basically a set of workbooks. And so if we're looking at cybersecurity for doing the basics, like if you're just focusing on the computer science, again, that's the prerequisites. These are all chapters. And so the step-by-step chapter on the terminal and using the microbit to communicate with it is here. Then we've got the Cyberbot and the electronics, the What's a Microcontroller. So these are all books, and then each tile is essentially a chapter. Are these free for students and teachers? Yes, the answer is yes. And so this that's the student-facing stuff, and at the end of some of those, you'll see questions, exercises, and projects, and then the educator resources for that is over here, where we need to log in. And so I'm going to go to learn.parallax.com on another screen and log in as an instructor, because basically if you are, for example, looking at the Cyberbot resources and you want the teacher material, it says no, you have to be logged in. There's some public facing stuff like standards, alignments, and slides that you can use similar to the ones that I'm going through right now. They're all on Google Drive for you. And then logging into learn.parallax.com as an educator, I'll get started. You go to educators or follow the link that was in the slideshow. And I guess I'll just do Cyberbot resources. and then I'm sorry, educators, and then we want to log in. And I'll be right back. I'm fumble fingering it here, sorry. Wow. Sorry about this.
I'll just say, yes. Leo mentioned that he just sent a request for an educator account. Hopefully I get approved soon. So if you're an educator and you would like access to these resources, just email me. You can email education@parallax.com, and please include a link to your teacher page on your school district website if you have not already in the application you sent for this course. And I will approve those and probably turn those around tomorrow. Andy, do I need to reset your password?
You might, just a second.
If you ever get locked out of your account.
Finally.
There we go. Okay.
All righty. I'm gonna have to change my passwords after all that. They say that now there's a AI algorithm that can basically listen to your key taps and figure out what your password is.
Wow.
Anyhow, all right, so here I am, and going back to educators, I can choose, we'll do cybersecurity since it's at the top. And now, instead of that giant lock, we see a link to assessment materials. And so writing microbit programs is one that we looked at earlier. So we'll go ahead and save the zip file of that and then take a look at it. Okay, so here is the zip file, and I'll just go ahead and grab the files from it. And paste them here. Okay, so here is a handout for the students that works on some of the concepts that they've gone through in the chapter. And careful to only print the first part for them, because after that we get to the red answer key material. And so that's how the educators portion of learn.parallax.com works. When you're logged in, you can get to all the available assessments in addition to what we have just public facing, which is typically, in this case, it's a teaching strategy guides. In some case, it's a standard alignment and strategy guide. There might be slides out here also. But anything for assessment, of course, is in a private area for teachers only. Okay, next up, yes.
Here's a comment. I usually use cyber.org, and I think I will use your content while creating the lessons.
Okay, yeah, mix and match. you know, to take the best and use it as needed. We both encourage that. Speaking of cyber.org, well, they're coming up next, but before we get to them, there's one quick thing I wanted to say about the remainder of Parallax resources, and that is you're in a workshop right now, and you probably got an email or saw a social media post. You'll get emails about future upcoming workshops, and there's also an events calendar. And I'll paste that into everybody. Now, this events calendar has it kind of has a dual purpose. The first is obviously, okay, well, gee, if you're interested in learning about the Cyberbot in March, you can view the event and you can apply to sign up. We actually send out robots for this, and it's 3 2-hour sessions, Monday, Wednesday, Friday. And so it's a very popular event. We also have a repeat of the For Beginners workshop that we're doing right now. And then we also have a cybersecurity workshop in April. So those are upcoming events that you can sign up for and potentially receive hardware to take the class. But there's also the past events, and that's for self-guided learning. And here is the most recent Cyberbot workshop. So for example, if you end up getting a Cyberbot for yourself, here are the video recordings at the top. These are the 3 2-hour sessions. And then here are the presentation slides. And, you know, you can go through each session, fast forward through the blah, 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 hit pause when there's an action item and try it out for yourself. So this self-paced learning of the Cyberbot is something I really hope a lot of people will take advantage of. Now on to cyber.org. Cyber.org is, as I mentioned earlier, it's a Department of Homeland Security funded agency that is works to empower teachers to spread cyber literacy and help increase the overall level of cybersecurity in the nation through the teachers to the students. And any United States K-12 teacher can sign up for this service. And once you are signed up, then you can hit the login button. So this is the web page right here. And once you log in, it takes you to a dashboard. And each of these tiles is a course. Now, for those of you who recognize this as Canvas, this is not something to share with your students. Once you're in cyber.org, cyber.org is the teacher, you are the student, and you're basically just going there to get the various course files that you'll be using in teacher guided. So we looked here at, you know, free tutorials that are available to the students. So these are, I'm calling that student guided. And then what cyber.org has is teacher guided materials. And the microbit course that they have, the microbit material, is here in coding fundamentals. And this is kind of between the cybersecurity level and the make it code it project level. So this is kind of a mid ground. And looking in here, there's the make code block version and the Python version. So once you open up your coding fundamentals tile, you have the option to gather teacher materials for either make code block or Python or both. Now, when you go in there, it has it broken down into lessons. And then those lessons are not identical, but they're very similar for both the make code block and the Python version. It just so happens that, for example, this display here is a different lesson number in Python from what it is in Make Code Block. And so looking at the courses they offer, it's worth joining, especially there might be other courses that would be useful to you for certain classes. For example, they have a very robust cybersecurity course that's for grades 10 to 12. But here we are for the microbit, and coding fundamentals is where the microbit comes in on its own. And then cyber literacy 1 and 2 is cyber.org's treatment, their teacher resources for the cyberbot, as opposed to our student resources with a little bit of assessment material. They instead have slideshows and then slideshow scripts. So taking a look at the example back in coding fundamentals, the microbit only one, I scrolled down a little bit. In fact, I scrolled to the end because they appended the coding basics with some cybersecurity content. And let's see here. Now I need to grab my downloads. Be right back. So since this is not restricted to US teachers, I felt obliged to just do everything offline as opposed to spelunking in their site for the demo. And so what I did was I downloaded the teacher notes and then the presentation for lesson 3 radio basics in their cybersecurity little endpoint sorry, I'm blanking on the name of the coding fundamentals. There we go. All right, and so after downloading that, they have a slideshow. And so and this is primarily set up for teachers to guide the students through the different parts of Python, in this case, radio scripts, and there's a separate one for the make code radio scripts. And then they also have some information for the teacher to read beforehand, as well as some notes for each slide. And so that's an example of a common way that cyber.org supports teaching various things, is with a slideshow and then a separate document that has the slide notes as well as course notes. You know, they talk about the objectives, materials, etc., time required, prerequisites, teacher notes, it's all in here. And they also have a technology grant program. It is not currently offering any grants, but if you sign up with cyber.org, so the last deadline was August 20th of this year. And so they had Chromebooks, Cyberbot robot kits, microbit club kits, those are the 10 packs, and external monitors. So those were all things that were available to teachers. And when they have their next round of grants, you'll get an email about it and a link to a page where you can learn more and apply. And they also have events. No way to make that pretty. Okay. Did I paste in that? Well, I guess it doesn't matter. The main link is just cyber.org. So let's make sure you've got that link. And that's where you can go to sign up. Make sure to use your teacher email so that they can check with you without having to reply. Because if you send from your teacher email, usually they can check your email and then look you up in the district and approve you without any further communication. They'll just send you more instructions after that. And then that's the technology grant. And then there's events. Sometimes you'll see a training, for example, that that course where I downloaded the PowerPoint file. They might have a training for that. Right now they have 3 going on, but it doesn't look like any of them are specifically microbit, but you'll see microbit stuff come up and they'll email about that. One last thing is there's also lots of good courses available through microbit. For example, here is microbit.org/teach/lessons, and there's the link to it. And let's go spelunking for music, and we'll do composition. And so here is their music bundle for ages 7 to 11, and you can download the whole unit and then unzip it. Let's see here. Refresh. And there's quite a bit of material in here. I trust the source. So, so each one is an enumerated teacher document and also a slideshow for the students, kind of similar to what cyber.org's doing. Let's see, where did that document go? There it is. And so it lays everything out for you in the teacher document, and then it's got the slides on, in this case, how to translate musical notation to microbit notes. So that's an example of one of many, many things available on the microbit site. This is just another page in the lessons for in this case, computing fundamentals. Another place to do some mining for different kinds of resources, if you haven't found what you're looking for yet, is makecode.microbit.org. What happens is if you go there, we've stayed near the top. So we've kind of been looking at the projects we've been working on, and then there's some really basic tutorials. But if you keep scrolling down, there is a set of courses. So like here's an example of Intro to CS online. And here's the entire course. And I would say hold off on going here and downloading until you're done with the Zoom meeting, because the package is really large. I want to say it was coming up on a portion of a gigabyte, but here we have lessons. So we can look at the variables lesson and look at their rock, paper, scissors challenge, and then talking about how to implement that on the microbit. So there's a place where you've got more material, and I have a slide devoted to just a few nuggets I found down here in terms of, well, Make It Coded, of course, is my favorite. Here's the CS intro. There's also a networking set of lessons. So that, again, there's a lot of good stuff. If you scroll down on the makecode.microbit.org page. This slide was here as a placeholder in case there was time to do the classroom activity. So just as a reminder, it was the open in classroom thing, which we already did earlier to see how you could look at what your students were doing with their code. You could share code, and you could share code with them as well and monitor their progress. Here we have the ways to contact Parallax for help. After this presentation will be available for any of you who had any challenges getting your microbit to connect. We want to help you out. We can also schedule a time for that later. Additionally, there's lots of opportunities for discussion and questions and answers. And so after 2 slides from now, we'll go ahead and finish up the presentation, and then we'll stop the recording and we'll continue talking for those of you who want to stay after, either to discuss or to get some assistance. So we have an educator hotline, which you can call to ask purchasing questions or to get help, especially if you're in the middle of class and stuck with some students are stuck, for example, and things are feeling a little stressful. Give us a call for microbit help there. We also have education@parallax.com. That's a good general email where we can route your email to the person who's best suited to answer the question. We have a sales department, forums for discussions, and then we're also on Facebook and several other social media channels. And for all those social media channels, you can go to www.parallax.com and scroll all the way to the bottom. And then we've got our Twitter, Facebook, YouTube, and etc., Pinterest, all the links right down here. Cyber.org sends their thanks. And thank you from us at Parallax as well. We hope you enjoyed this and that it will be very useful in your teaching of computer science, robotics, electronics, and cybersecurity to your students. Thanks for coming, everyone, and we're going to move on to the questions, answers, and tech support portion of the presentation.